Okay, so problem 1 on the review, we have an explanatory variables of hours that you're studying for a giant exam, and the score that you get on the exam. In the Y column, that's the response variable. This feels like it's a horrible test, okay? So right now you're finding the least squared regression line, correlation coefficient, and coefficient of determination. So of course, the first thing we're gonna do is just put it in the calculator, stat, edit. My X is in list 1. Yes, and you see nothing. Thank you. And 75, 70. I hope it doesn't take you 5 hours to study for an 87, but you never know. I've been there, done that. Okay, so then stat, calculate, number 4, list 1 and list 2, nothing in the frequency list. If you want to store it, you can, but you do not have to. So that's vars, y vars, function y1. And there's your equation. So my regression line is the LSRL, which is my line, is y hat equals 2. I guess I'm going to have to round that up to 2.40x plus 70.5. Okay, that's my regression equation. I have no R and R squared because my diagnostics got turned off. So I'm going to go to mode, or you can go to catalog. Now if I did it again, sorry, there's just a huge lag on this thing. All right, so my R, which one is my R? Correlation coefficient or coefficient of determination? Correlation coefficient, R is 0.9147 and R squared is 0.8367. Question. The test specifies this to the 3rd decimal place. And then this is where you're going to want to show your work and everything and upload it, because if you just rounded wrong, I'd go back and give it to you if you had work. So, all right. So we have this. Okay, linear correlation coefficient. I want what is the critical value now? Well, let's look at this. What does the R tell us? Jacob. To get all of this? Yeah. Just stat, calc, number 4, list 1 and list 2. Frequency list blank. Store regression equation you can put in if you want. Calculate. And I'm actually going to draw this real quick. So second stat plot, again, you don't have to do this, on. And hit zoom 9 so you can see it. So this is my case. Okay, here's my picture. So looking at it, it looks like there is a strong positive linear correlation. You guys good with that? But there are only 4 data points. So it's kind of hard to tell if that's really it. So I need the critical value to compare my R to. So the critical value comes from your formula sheet. It's also in your notes. I'm going to pull it off the formula sheet this time. So, guess it's not on this one. What? There we go. Sorry, I'm trying to find the most current version of the formula card. Nope. Here it is. All right. So critical values then. We have 4 data points. So the critical value is 0.95. You guys all have this table in your notes. Okay. Critical value is 0.95. And so what I'm going to say is I have to look at the absolute value of my R. The absolute value of R in this case is 0.9147, and that is not bigger than 0.95. So what does that mean? Oliver? Correlation. It looks like there's correlation, and there might be, right? But we're saying, you know, if there's only 4 data points, to really be sure, we'd need our R to be above 0.95, and it's not. So this could just be a fluke, okay? Yes. Then what the table is, the absolute value of your R. Now we're gonna go ahead and finish the problem with this anyway, and assume that it's not a fluke. But as a statistician, I might say, you know, I better get some more data first and try again to see if it really is correlation. So on that note, ignoring the fact that this happened, okay, what does our coefficient of determination tell us? Oh, I saw Jacob first, whoever. Except for you need to look at the R squared. Jacob. Yeah. There could be. So that one, you look at the point, you have to look at this. Now let's say this was bigger than 0.95. I would have then called this strong. So I gave you guys that rule of thumb. I look at anything above 90 as strong. But you can start to argue even 80s are strong or moderately strong. Just looking about how well the points fit the line. If it's close to 1, if it's strong. If it's 70s or 80s, it's moderate. If it's less than that, it's weak. Just off the R value. Okay. And then for the other one, what I was looking for was that 83.67% of the change in test scores can be explained by the least squared regression line. Now, I actually preferred, okay, how she said it in that I prefer it to say 87.6% of the change in test scores can be explained by how much you study. Okay, that other 13% is maybe you didn't sleep well, maybe you weren't paying attention, maybe you had them, I don't know, okay? But it's just that this is the percent that your prediction line is based off of your X, okay? We've got our least squared regression line. What would I predict a kid would have? What would their score be if they studied 5 hours? Now, one kid had a score of 87, but what would I predict a kid would have if they studied 5 hours and it wasn't a specific kid? What would my prediction be? How would I figure that out? Tyler. Plug in the 5. So y hat, somebody do it for me real quick. What do you get? 82.5. So this is my y hat. If I wanted a residual, that's y minus y hat. Well, the one kid that we know for sure that did 5 hours of homework got an 87 minus our prediction, right? So our residual is positive 4.5. Now, if we go back and look at the graph, how do I make this sucker bigger? Let's see. Nope. Nope. Come on. Okay. This is where This is the 5. It's saying the actual kid was 4.5 above the predicted kid. That's all that that's saying. Okay. So a great question was then, how could you find all of those based off a list? Go to Stat, Edit. After you've run linear regression, go up here, and you're going to go second list. It only works if you've just run linear regression, and it's wherever it says residuals. Notice that my cursor was up top. I hit enter, and hey, look, there's my 4.5 residual that I was talking about right there. Good question. Now, how would you interpret the slope of this equation? Let's see if I'm still. What is this? How would you interpret the slope? Guys, let me just tell you. For every 1x, so for every extra hour studying, or every hour studying, your grade on the test will go up by 2.4%. That's what it's saying, okay? For every 1x, this is what happens to your y. And then on this case, it says, what about my y-intercept? If my y-intercept was 0, I could plug this in. Well, that would be this. If you didn't study at all, you're probably going to get a C. That's what this says, 70.5. Okay, and then you have to look to see if it makes sense with the real world. All right, that's chapter 4. Now let's look at chapter 5. Oh, we're looking at a population of people and whether they have a garage in their house, a pool, or both. Okay, so all right, so here's my picture. I totally made it up. I don't know what the numbers are going to say. Okay, so this is my table. All right, and I want the marginal frequency for owning a pool. That's the first thing I want. Number 2, I want the marginal frequency for having a garage. Okay. Number 3, the probability of you owning, let's see, of no garage. Number 4, the probability of having a garage and a pool. And I want the probability. And then 5, a pool given you have a garage. See if you can find those things for me. I'm assuming that you guys then figured out the marginal totals, right? The marginal totals. So if I say, what is the marginal frequency for owning a pool? It just means how many people owned a pool? 42. Okay. The marginal frequency for having a garage, 92, right? Then it says, what's the probability that you don't have a garage? If it doesn't say given, your denominator is always this. So no garage. Well, how many people don't have a garage? 50. So 50 out of 142. Okay? Probability probability of garage and pool, well, how many people have a garage and a pool? I want to be them, I am not. That would be 32 out of 142. Okay, pool given you have a garage. Well, now we only care about the people that have a garage. So how many people have a garage? 92. Of those 92, how many have a pool? 32. Okay, that is that given formula that you're used to. But we're not making you use it, we're just making you use the table. Okay, now what if I asked you, is having a pool and a garage independent? What would you do? Any thoughts on that? Okay, so there's two ways to do this. The first is that we know the probability of pool and garage, if they're independent, and I have no idea if this is true or not because I made it up, is the probability of pool times the probability of garage. Okay, this is the multiplication rule for independence. So probability of pool and garage, well, that's 32 over 142. Well, somebody figure out, we'll figure out what that decimal is. What's the probability of just having a pool? Well, that's 42 out of 142, right? Because how many people have a pool? What's the probability of just having a garage? 92 out of 142. If these are independent, they will match. 132 divided by 142 is 0.929, basically 93. This really rounds up to 0.93. And then the other one, and I have no idea how this is going to turn out because I made it up. Oh, yeah. Are these independent? No. Okay, they're not independent, which means maybe knowing that somebody has a garage makes it more likely they have a pool, right? If you have a pool, how many houses do you know that have a pool that don't have a garage too? Okay, could you have a garage and no pool? Yeah, but if you have a pool, probably going to have a garage because that just tends to be one of those more expensive houses that it's got a pool, it's going to have a garage too. So they're related in some way. Knowing somebody has a pool might give you a hint that they have a garage, or knowing that they have a garage might make it more likely they also have a pool. The other way to look about that is look at this one. The probability of pool given garage is 32 out of 92. If these things are independent, that should be the same as just the probability of having a pool, because knowing somebody has a garage won't change it. Well, what's the chance of having a pool again? 42 out of 142. And I tell you, if you did these decimals, they will not be the same. Okay, so let's check them real quick. I only know that because the other test failed. I didn't round well on that. Notice they are not the same, so they are not independent. Yes? Oh, it's not. I don't know what I typed in. It is, and they still don't match, but that makes a heck of a lot more sense. Good catch. Yeah. They still don't match, but they match in a better ratio than they should have. Yeah. So independence is either one of these, okay? And just think, the whole thing with independent is, does knowing one change the probability of knowing another? Okay? With replacement or without replacement? And when they say probability, they could also say proportion, right? Find the proportion that have this or that. So it doesn't have to just be probability. All right, let's skip to something else. I think you guys do okay with, you know, we're pulling marbles out of a bag, whatever. But you still also need to know how to do that stuff. And you need to know how to do, like, I guess we could do, let's see, we have, let's look at a deck of cards, right? What's the probability of getting an ace and a red card? That means a red ace. Remember, you could just think about it. How many red aces are there? One, because there's aces, right? Oh, sorry, 2 red aces out of 52, right? Or you could use the multiplication rule, which is the probability of getting a red ace. Well, that is, of getting an ace, that's 4 out of 52, times the probability of it being red. Well, what's the chance of it being red? 1/2, right? Half are red, half are black, which would then give you 2 out of 52. Remember, and is multiply, or is add. So if we wanted the probability of an ace or a red card, that's when you would add. You would say the probability of an ace plus the probability of a red card minus the probability of an ace and a red card. What's the chance of it being an ace? 4 out of 52. What's the chance of it being a red card? 1/2, or 26 out of 52, right? Minus, how many red aces are there? 2 out of 52. And that would give you your answer. And that works because you've counted all the aces, you've counted all the red cards, but in counting the red cards, you counted these aces twice. So you had to subtract out the overlap. You guys remember that? So don't forget in chapter 5, the multiplication rule and the addition rule. This is and this is or. Don't panic about it, but you just need to know how to do it. All right, so let's move on then to, what if I said, of my class of 30, how many ways can I pick one group of 4 to give a presentation? What would I do there? Guys, is that a combination or a permutation? What do you think? Combination, right? If I pick a group of 4, it doesn't matter if it's Amy, Billy, Charlie, or Dawn, or if it's Dawn, Amy, Charlie, or Billy, that's still the same group of 4 kids. So think about it as a pizza. Okay, the topping order doesn't matter. So you would do 30, choose 4. And I'm not even going to play with the formulas. I don't care about the formulas. They're great to know, but for the test, if order doesn't change the group, then you just hit 30, math, PRB, 30, choose 4, and there you go. There are 27,405 different groups I could make. It's out of control. Okay. Question, how many ways could I award the top 4 grades? So now you'd want to be first place, second place, third place, or fourth place. This one, Amy's happier. this one, Dawn's happier. So now order matters, right? They're different. How many ways can I arrange the top 4 grades? So I would do 30 choose 4, and there's a ton more because all of those other groups before that we said were duplicates are no longer duplicates. Okay? Questions on that? All right, lastly, how many ways? Yes, Jacob. Yeah. So you always hit the first number first, then you hit math and scroll over to PRB. Is that working for you? And then you would just do, like if you wanted to choose, and then the other value. All right, so let me resume the video. So how many ways could you order the letters in the misspelled word mathematics? Okay, and in this case, it's different than the other two because we have duplicates. So the way you do that is how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that goes on the top. That's the total, 11 factorial. All over all of the duplicates. Okay, so we think, well, how many duplicates are there? How many m's are there? 1, 2, so that'd be over 2 factorial. How many a's are there? 1, 2. Okay. How many t's are there? 1, 2. How many h's? Just 1, so we don't care. How many i's? Okay, really just 1, but based off of my bad spelling, 2. How many c's? 1. How many s's? 1. Okay, so then you'd put it in your calculator as 11 math. I guess I didn't need to make that an I had enough duplicates, but I will. 11 factorial, and you can hit enter and get the number, but divided by, and now this next part, you'd either need to do it separately or it has to be in parentheses. 2, why did I pick such a big number? Factorial, 2. You don't have to do it all at once. You could do it separately. Factorial. This was stupid. Should have picked something easier. 2 factorial. 2 factorial. Notice you either do the numerator and get the number, the denominator and get the number, and then hit enter. Yes, question. You could be smart enough to do that, yes. The reason I didn't is because often it's not the same number. But you absolutely could go 2 factorial to the 4th. And you should get that many ways. Yes, Jacob. Of the letters in the word mathematics. No. Total random ordering of the letters. Okay, so that's chapter 5. Lastly, we just need chapter 6. Okay? So chapter 6 is 2 separate things. The first would just be random variables in general. Okay, and that's a chance thing with different probabilities. So rolling a die. Okay, if you did that, these are your options. You could get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, and the probabilities of getting a 1 is 1/6, A 2 is 1/6. A 3 is 1/6. The 4 is 1/6. Obviously, I picked something easy. And if you had me an A day today, this is a uniform probability distribution. We don't care about that for 6.1, but it's uniform because they all have the same probability. And if you were going to make it, you'd say, okay, this is my random variable. X equals the number on the die. Okay? And this is the chance of it happening. It is a legit probability distribution if these add up to 1 and they're all in between 0 and 1, right? Because they need to add up to 1. What else do we do with that? Now we could have a story problem, such as, okay, you're going to buy an insurance policy. And hold on, let me just do something real quick. I'm going to change my story problem, okay? So what if we're going to play a game? We're going to play a game, and you have to pay me $3 to play. Okay, you win if you draw a face card. And if you win, I pay you $50. Okay? If you don't draw a face card, I get to keep your money. So let's make a chart. So first off, X could be two things, right? And the situation for this could be you win or you lose. Okay? Now I want to look at it from the dealer's point of view. Okay? If I look at it from the dealer, well, let's look at it from you, it'll be less confusing. We're looking at it as you playing. Okay? If you win, what is your profit? 47. Okay? X is your profit. If I just said, instead of X, I said Y, Y is how much you win, then you would say 50. Does that make sense? So you have to be really careful with these questions. Are they talking about your profit or just what you win? If it's an insurance company, because they've done that a lot, right? Are they including the fact that you paid them a premium or not? So go back and look at those examples and just make sure you can see the keywords for that. Now, if we're just talking about the profit, if you lose, your profit is negative $3. However, if we don't care about profit, if you lose, how much do you win? 0. So the tricky thing is which one are they asking for? Okay. So you're looking at the story problem for that. I'm going to go by profit here, not what you win. All right. Now we want the probability. What's the probability that you get a face card? Well, there are 3 face cards times 4 different suits. So there are 12 face cards out of 52. Jack, Queen, King, 4 per suit. What did I just do? Yeah, Jack, Queen, King, 3 per suit times 4 is 12, right? And then the chance that you lose then would be 40 out of 52. Question, what is the expected value of this distribution? What would you do? What's the average? So the expected profit, so I'm looking at these are my variables. The expected profit would be the sum of every value times the chance of it happening. So 47 times this, negative 3 times this, and add them up. However, I'm just going to put it in my calculator, stat, edit, Okay, list 1. I'm going to say 47 and negative 3. Okay, they're not going to have all the tricky stuff that you have on your homework. What you need to just be able to do is to understand the situation enough to know if it's this column or this column, okay? They're not going to do all those really tricky ones that were in 6.1 on your homework, because that's not the point. And then what's the chance of it happening? 12 out of 52 or 40 out of 52. So there's my variable, there's my probability. Stat, calculate 1 variable stats, list 1, comma, list 2. And my average is 8.54. Okay, I promise you if you did 47 times 12 over 52 plus negative 3 times 40 over 52, you'd get 8.54. And my standard deviation is 21.1, basically. So just get those out of the calculator. Make a table and get it out of the calculator and you're good to go. So what would I expect to happen if I played this game once? Lose $3, right? 40 out of 52 chance I'm going to lose. What would I expect to happen if I played it over and over and over and over and over again? On average, I'd win $8, but I'd have to play a bunch. I'd lose a bunch before I won enough to be positive $8. Okay. All right, so that's 6.1. Lastly is 6.2. You guys are going to do just fine. All right. So then we have this special type of random variable, right? A binomial. And it has 4 things that makes it binomial. Yes. Yes, sir. Great question. So X bar is your expected value, and then that is your standard deviation. Nothing in the frequency, well, frequency list is the probabilities, right? How likely is it to happen? So L1, L2. All right. Okay, last but not least. Okay, how can you determine if something is a binomial distribution? Okay. What if I said random sample of, 20 Hillcrest High School students are asked, did you pass all your classes Q3, right? And I'm going to say the probability they pass all is 70%. Okay. Is this a binomial? Well, remember, we're checking bins. So B, is it yes or no? Success or failure? Is it B stands for binary. Is it a binary question? Yes or no? Yeah. Did you pass all your classes or not? I, independent. If I pass, is that going to affect if your friend passes? No. That's excluding boyfriends and girlfriends that maybe help each other. Well, I mean, like, I know that if I had a boyfriend that studied, I studied more. Does that make sense? Or you have a study group or whatever. Excluding that you're studying together and helping each other, do your grades affect your neighbor's grades? No. Okay? So yes, it was independent. N, did I ask a fixed number of students? Yes. If I just said, I asked Hillcrest High School students, did you pass all your grades? How many did I ask? If I don't say how many, that doesn't work. And then if I had left off this last sentence right here, which I almost did, we wouldn't have had S. And in this case, S almost doesn't make sense, because does everybody have a 70% chance of passing all their classes? If I'd say so, yes, and then it's a binomial. But in the real world, no. How much you studied, the type of classes, etc. You have it totally depends on each kid. So if I had left off that it was a 70% chance of everybody, then the answer is no, it's not a binomial. But since I put it in there, the answer is yes.
But even if you did, so assuming that everyone's ability to pass is 70%, wouldn't that change the probability of failing to 30%, and then they wouldn't be, the success rate wouldn't be the same?
Oh, it's not that the success and failure rate is the same, it's that every kid has a 70% chance of passing, and every kid has a 30% chance of failing. It's the kids, not the binary. Good question. Okay, so let's assume, although it doesn't make any sense, that every kid has a 70% chance of passing. Okay, Mr. Levitt would lose his mind if that was the case. Not the case, but let's assume. Then I ask the question, and then we're done after this, guys. This is it. What is the probability that exactly three of the kids I asked passed all their classes? What would I do? Yes. Oh, please just use the calculator. So literally, Oliver, tell me. Yeah. You didn't. It was perfect. That was my next question. Done. What'd you get? E to the -7.
Yeah.
So really 0.6504, basically 0% chance. This is what we did for the warm-up today. Yep. If this was not an online test, I would want to see, and I really kind of do want to see this on your work, that this is N, this is P, and this is X. Again, if you wanted the formula, which you're kind of getting out of this year, you'd say 20, choose 3. How many ways could I get 3 people to pass out of 20 with 3 successes, and that would leave me 17 failures. Okay. So what if I said probability of X, because X is the number of kids that passed, being less than or equal to 3, what would I do? Just calculator speak. I know Oliver knows, but I'll let her do it since. Oh, yes. Yes, exactly 3. Only 3. Right. So this one is exactly 3. This one would be less than 3. So your options could be that nobody passes, 1 passes, 2 passes, 3 passes, okay? All the way up to all 20 kids pass. Nobody passes out of 20 kids, Mr. Levitt just fires a teacher. Okay, I have a conversation with one of my department members. Anyway, we did have that one year. Anyway, so less than or equal to 3 would be these guys, right? So let's just talk the calculator cheat, yeah? Binom, CDF, 20.7 and 3, but that's going to give you 3 or 2 or 1 or 0. This always goes to the left. So the difference really is PDF is exactly 3. So you're only saying, what's the probability of exactly 3? And that would be the same as using this formula. CDF is this number or less. So that's the idea that it only goes to the left. It's going to add up 3 or 2 or 1 or 0. Yes, question.
So with the dot with the answer, it's the exact same as the PDF.
Exactly. Yep. Yes, but let me do it real quick. So if I wanted the probability of X being greater than 3, well, we know that there's a 100% chance, i.e. 1, that something out of there is going to happen, right? So greater than 3 would be 4 and above, would be these guys. So we'd say 1 minus these guys, so minus this answer, and you would have above. But that's greater than 3. Okay, so the trick is, if I wanted the probability of X being greater than or equal to 3, it would tweak a little bit. Because I would do 1 minus binom CDF 20, comma 0.7, comma 2, because I don't want to subtract the 3. This one, 3 needs to be included. So when I did it, I would subtract just 2 or less, so I could keep the 3. So you have to just be really careful. Does it want 3? If it wants 3, then the number right here is not going to be 3. If it doesn't care about 3, then the number right here could be 3, because that's what you subtract, that many or less. Okay. I also ask you, what is the expected value? Okay. What is the expected value? The mean why is this not working now? Okay. The mean of a binomial, okay, and a binomial, you say X is approximately binom distributed. Okay, you ask n people and you have this many for a success, is n times X. That's the mean. So in our problem, I talked to 20 people and there was a 70% success rate. So whatever 70% of 20 is, that's the mean. Okay. The standard deviation for a binomial is the square root of n times p times q. So the square root of 20 times 0.7 times 0.3. So again, remember that mean is the word expected. Mean, average, expected, they're all the same thing. So every time I ask 20 kids, I'm kind of expecting 14 to say they passed, because that's 70%. Now, every sample is going to be a little different. And how much does it vary? This would be by about 2 kids. So anywhere from 12 to 16 would sound good to me. That's what I would expect. Okay. Now, is this going to fit a normal curve? I don't know. Okay. But, no, the answer is no. But we know it's going to look like this. It's going to sit around 17 with about a 2 standard deviation. But is it going to be 68% between here and here? Is it really normal? I only know if n times p times q is greater than or equal to 10. And in this case, it's going to be 4 something. It's 4.2. 4.2 is not greater than or equal to 10. So if I found out the values between here and here, I don't know what it's going to be, but it's not going to be 68. If this number was bigger than 10, then I could have just done the problem as a normal instead. That's the whole unit, guys. Any last minute questions? Oliver.
Can you like explain your examples, like when you're taking a balance, so you have to subtract it by?
Yes. Okay, so let's do one other example. What if I said, let's do this one. Let's do the percent that is in here between 14 and 16. Okay, we know it's not going to be 68. Might be close because it's the same shape, but not quite. So what we would do is, no, I don't really want to do that. Okay, hold on. Okay, so there's our picture, right? Those are the things that could happen. 0 up to 20 people passed all of their classes. And I'm asking how many passed between 12 up to and including 16. Okay, so the probability of my random variable being between 12 and 16. If this was 10, guys, we could have just done normal CDF, 12, 16, the mean, the standard deviation, and we'd get the answer. But since it's not, we have to use the stupid binomial stuff in the calculator, and that only goes to the left. So that's why he asked this question, because we would say, okay, what is this probability? Binom CDF out of 20 kids, chance of them passing all their classes is 70%, and we want the probability of 16 of them, minus binom CDF 20.7 comma, what's going to go here, 16 or 15, Oliver? Or question? I said 16 or 15, but neither would be correct. 11 or 12? 11, because we want to subtract these guys. And then you'd get the middle. And again, if this was greater than 10, I could have skipped the middleman and done normal CDF, 12 to 16, with that mean of 14 and the standard deviation of 2, and it would have given me the right answer. But you can only do this if this thing doesn't work. And that's not going to show up yet. Okay, we're introducing it to you for future chapters, so you don't really need to stress about that. You would get the same answer. Yep. And so it doesn't matter. But I would just use binomial for this unit in this test because we've talked about it, but we haven't done it much except for the homework. This one? What's the probability between 12 and 16 kids having passed all their classes? Anything else? Yep. Yeah, it's 0.3 because it's if the chance of success is 70%, then the chance of failure is 30%. So the question would be, we want 12 through 16, so we wanted these guys. So if you want these guys, dang it to heck. Okay. If you want these guys, you don't want to put 12 right here because then it would include 12 to what you're taking off. So if it said greater than 12, less than 16, then it would be something you would do 15 and you would do 12. I always draw these pictures. Like I legit draw the picture. If it had said this, we want it greater than 12, but less than 16, then you would have put the 12 in because you wanted it greater than 12, but less than or equal to 16. So I every time draw these little pictures and then I know, oh, I need to cut out the 12 too or I don't. Does that help a little? So if it's saying greater than 12, subtract the 12 out. If it says greater than or equal to 12, you will need to keep it. Upper one, if it says greater than or equal to 16, you want to put 16. If it just said, or less than or equal to 16, if it just said less than 16, then you wouldn't want the 16, so you would put in 15. So that's why I always draw it, because otherwise I'd mess it up. Because if you were to put 17 right here, it would include the 17. Whatever you put is included. So for that first one, the top boundary where we wanted it 16 or less, we don't want to include 17, so you don't put 17 here, because that's the top boundary. The bottom, if you put 11 right here, it includes 11 in what you subtract, but that's okay because we wanted to keep the 12 on the inside. So the top is different than the bottom. Yes. Of course.
So with the playing the game and making noise today, after you put 27 and -3, and then 12 out of 52 and 40 out of 52 in the list, where do you go from there to get
Stat, calc, 1 var stats, L1 is your variable, and L2 is your frequency.
okay, thank you.
Anybody else? For a little bit.
Okay, I just have one.
Yep. Anybody else? Okay, I'm going to post this